Okay, today we are going to be doing an intro to minerals. We're going to watch this video real quick and then get into our PowerPoint presentation.
Hi everyone. In this video, we're going to be talking about minerals. So let's get started. What are minerals anyway? Well, in the simplest sense of the term, minerals are the building blocks of rocks. Here's a rock. This is a piece of the igneous rock called granite. If you look carefully at this chunk of granite, you'll see all sorts of speckles of gray and white and black. And if you zoom in, you'll see that these are actually crystals, mineral crystals. This particular piece of granite has the mineral quartz, biotite mica, and plagioclase feldspar. We'll study these in more detail later on. So, on Earth, there are over 2,000 varieties of minerals, some of which are seen here. As you can tell, they come in a wide variety of colors, shapes, sizes, textures, and all sorts of different physical characteristics. Minerals have quite a few uses in our everyday life. Just to give you an example, this here is a rough uncut diamond. Of course, we use diamonds for jewelry. We also use diamonds in construction applications, as the tips of saw blades, and a variety of other industrial uses. Here's another mineral. This is called fluorite, most famous for its inclusion in toothpaste. Yes, when you see the name fluoride on a toothpaste, that means it's made out of the mineral fluorite. But what else are minerals used for? Well, this here is talc. Talc is a very common mineral that is ground into a fine powder. It's very soft, and it's used in baby powder. Sometimes you might hear it referred to as talcum powder. One more example. This is the mineral selenite gypsum, which is used all around us in drywall. This is the material that's used to build the walls inside modern houses and buildings. But what exactly makes a mineral a mineral? Well, to be considered a mineral, the substance must meet 5 criteria. Let's go through those 5 criteria right now. Number 1, the substance must exist as a solid under normal conditions on Earth. This means if you have a liquid or a gas under normal conditions, it cannot be considered a mineral. It must be in the solid state. Number 2, the substance must be naturally occurring on Earth. This means it cannot be man-made. So, for example, plastic is not considered a mineral because it doesn't exist naturally. It's created by humans. It must be naturally occurring. Number 3, the substance must be inorganic, meaning not coming from living or made of living things. So, if you talk about, tree branches or leaves, they cannot be considered minerals because they are organic. That is, they came from living organisms. Another example would be coral. Coral is made by small sea creatures, and therefore it's organic material and cannot be considered a mineral. Minerals must be inorganic. Number 4, the substance must have a fixed chemical formula, meaning it's made up of a specific combination of elements. Let me give you an example. Mineral quartz is composed of silicon and oxygen bonded together, specifically one silicon bonded to 2 oxygen atoms. All quartz is made of this chemical formula. Another example, pyrite, often known as fool's gold, has a chemical formula of Fe, which is iron, and S, which is sulfur. And when these are bonded together in this particular arrangement, you get pyrite. So criteria 4 is that the substance must have a specific or fixed chemical formula. It has to be made of a specific recipe, if you will, of elements. And then finally, criteria number 5. The atoms that make up the substance must be arranged in an orderly crystal structure, a specific structure. Let me give you an example of this. The majority of the minerals that exist on Earth's surface are considered silicates. And that means they're made up of, in part, silicon and oxygen. The silica tetrahedra is the most common arrangement of silicon and oxygen atoms within a mineral. It looks something like this model here, where the red balls of clay represent oxygen atoms and the gray is a silicon atom. And you can see they're bound together in this tetrahedra shape, and this becomes the most common building block of minerals on Earth. So that's what we mean with
Attention.
All right, and we're going to pause right there for a second. Okay, so now that we're at our properties of minerals, we are going to go into our essential questions. What properties identify a mineral? How are different minerals identified? What are some common uses for minerals? If you were quizzed today, which questions would you know the answers to already? You'll put your answers over here. Which questions would you need to learn more about to answer confidently? Put your answer here. Brainstorming. What are the difference between rocks and minerals based on the video that you saw? Give me 3 examples, 3 rock examples and 3 mineral examples. The similarities of rocks and minerals. They are inorganic compounds, non-living. Both can be classified by their chemical composition. They are solids. They are naturally formed, and they are found around the world in many of the same places on Earth. Now, based on what we have here, you're going to take and you're going to list the commonalities between rocks and minerals right here on the Venn diagram. Look at the map of the major mineral mining operations in Western Hemisphere. They look at the map, then look at the map of the major tectonic plates. What similarities do you notice? So, you have all of these mining places that are along the coasts here, around this on the left side and some on the right. Can you tell me where you find the most at? Write down the similarities that you notice right here. Rocks, most commonly classified by how they form: sedimentary, metamorphic, and igneous. They are composed of more than one mineral. There's no definite chemical or composition. There's no definite crystal structure. Rocks. On the left side of the Venn diagram, you will list the characteristics that are unique to the rocks. So you can go back to slide 7 and look at those characteristics. Pardon me. And list them there. I need at least 3 of them. Minerals. In addition to being inorganic, solid, naturally formed like rocks, minerals have a definite chemical composition, which means they have the same mineral, will always have the same amount of elements present. A definite crystal structure, which is a unique arrangement of atoms and molecules. On the Venn diagram, you will take, and on the right side, you will list unique characteristics for minerals. Here you're going to classify what each picture is. Is it a rock, or is it a mineral? For instance, let's do the first one together. If this was a rock, then I would move it over here and put it to rock. If it was a mineral, then I would move the mineral over here, like so. Okay? Now, the properties of mineral. Mineral identification is important vocabulary. We have color, which refers to the color of the mineral. Streak, which is the color of the streak across the plate, luster, which is metallic or non-metallic, hardness, which is Mohs hardness scale, density, which is specific gravity, or breakage pattern, which is cleavage and fracture. Color. Many minerals have distinctive colors, but they come in a variety of hues or in shades. Colors should never be used as the only test for identifying a mineral. Using these images as a reference, why can't color be used to identify a mineral? So here is gold, and then here's pyrite, which is also fool's gold. You see how they look both gold, but they're actually two different minerals? Can you please tell me why color should not be used? The color of a mineral displays a finely powdered form. It might be completely different from the color of the mineral itself. To determine the streak, rub the mineral across a piece of unglazed porcelain known as a streak plate. How do you find the streak of a mineral? Look at these points and tell me how a streak is found. Metallic looks like this. It has a metal-like shine. Non-metallic has a non-metal-like shine. A non-metal-like shine is glassy, which is quartz, pearly, which is talc, greasy, which is graphite, silky, which is gypsum, resinous, like sulfur, and adamantine, like diamond. Mohs hardness scale. One of the most reliable ways to identify minerals. Compares the resistance of a mineral to being scratched by 10 different minerals. This is called Mohs hardness scale. It's named after German mineralogist Friedrich Mohs, who developed the scale in 1812. Density is defined as the amount of matter per unit in volume. Density is found through mass divided by volume. In the minerals, the term specific gravity is used in describing density. In this way, minerals can be compared and identified. Cleavage refers to the way that minerals break along certain lines of weaknesses of their structure. Mica is a good example. So right here you have muscovite, and it only has one plane because the top and the bottom counts as one plane. Then you have feldspar, which has two planes because it has one right here and then two on each side. Then you have halite, which is used for salt. It's cleavage in three directions. So you have 1, 2, that's one. Then one right here down the middle, 2. And then, of course, you have side to side, which is 3. Then you have calcite, which is cleavage in two directions at 30 and 120 degrees. Because it has a cleavage in two directions, it has 4 planes. Fracture is a description of the way a mineral tends to break. Some different types of fracturings is the conchoidal, which is smooth, curved, hackly, which is sharp and jagged, uneven, which is rough and irregular, and fibrous, which shows fibers. Now that we've gone through this, you're going to take and you're going to match the definition to the word. Okay, so for color, for example, if we were going to do color, color would be over here. And I would take it and set it like so. What 3 element minerals have you used in the past week, and what form were they in? So if you use table salt, you've got table salt. If you've drawn anything with a pencil, you've used graphite. If you've cut with anything or worn jewelry with diamonds, then you've had diamonds. If you've plugged in your iPad, you've used copper. If you have used your electrical equipment, such as your iPad, you've used silver. These are all great examples. I want you to list 3 and tell me how you use them. Minerals are resources that we use for many purposes. Based on their uses and the scale of time it takes to make new minerals, are minerals renewable, which means that they are self-replenishing, or non-renewable? Put your answer there. What is your birthday gemstone? Mine would be ruby because I was born in July. My son's would be aquamarine because he was in March, my youngest son at least. And then my oldest daughter would be December. My husband and my oldest son's birthday is in October, so it would be opal. I'm sure you get the drift by now. So tell me, what is your mineral? Some minerals are cut to become precious gemstones. This is another use for minerals. So what's your birthday gemstone? Right here, you're going to select one of these and you're going to tell me, if you were looking for minerals, what minerals do you think you would find in one of these? For example, we have the computer. It has a cord. It has copper in it because it has a cord. It has an electrical cord. Now you will take and match up the inorganic to the word here. So what does inorganic mean? Inorganic means that it is made of something that cannot be made, that is not living. So I would take and I would move non-living over here, just like that, okay? And so on and so forth until you've matched each one of these up to the appropriate place. All right, now you're going to do your best to answer these 3 questions. Describe the properties that identify a mineral. Determine how different minerals are identified. List common uses for minerals. What essential question do you think you still need help to understand? So we're going to scroll back up here to the very top and we're going to look at our essential questions one more time. What properties identify a mineral? How are different minerals identified? What are some common uses for minerals? You're going to take a look, and if you feel like you can answer all of these, then type that you feel comfortable answering all of them. If not, then tell me which one it is and why. And if you have any further questions, feel free to ask. You have makeup work that needs to be done, and substitute packet work that can be done as well.